All right. So, continuing with part 4 of this series, now we are going to look at the detection of radioactivity. If you have alpha, beta, or gamma radiations in a room, how would you be able to tell? What is the way in which you can detect these radiations? So, the first thing that we're going to use is something called a GM tube, a Geiger-Müller tube. This tube looks like this, and it's connected to an electrical circuit which has a rate meter or a scaler. So this part is the tube, and this is the counter, which can be a rate meter or a scaler, which will count the radiations. So first of all, we have a very thin mica window. Now why is it thin? So that even the least penetrative of the radiations like alpha radiations can enter the window, and beta and gamma radiations will enter easily. So once they enter this chamber, it's basically covered by a metal tube. Now the metal tube is negatively charged, and the electrode in the center is positively charged. Okay, so the central wire here is positively charged. So we basically have an electric field inside the GM tube. Now what happens is, you know that these radiations are ionizing. So the gas that is inside the chamber gets ionized, and by ionized, it basically, the atoms of the gas gets broken into ions and electrons, positively charged ions and negatively charged electrons, and they get attracted to the oppositely charged electrode. So electrons will go towards the towards the positive electrode, and the positively charged ions will go towards the negatively charged electrode. And this basically creates a voltage inside the tube, and there's a spark that occurs, and it sends a pulse of current down the circuit. Now because there's a pulse of current, the rate meter counts it as one radiation being detected, and the more pulses, the more radiations that are caught in the tube, the more the count on the rate meter increases. So if it is a rate meter, it will give you counts per second, or sometimes it can be minutes, it can be hours as well. Depends on the settings that you have on the rate meter. So it basically tells you the number in itself doesn't really mean anything, because it's not actually telling you the number of alpha particles in the room. It's only telling you the alpha particles that it has caught, or the beta particles that have been caught, or the burst of gamma radiations that have been detected by the GM tube. So the bigger the number, obviously, the more the amount of radiation. So if you have a big number on the rate meter, that means there is a large amount of radiation in the room, and if you have a small number, that means there's less amount of radiation in the room. Now you can also connect it to a loudspeaker, which makes a click sound every time a radiation is detected. Now this will not really give you any count or any number, but the more clicks you hear, that means the more radiation there is. So it can work as an alarm that you can wear on your jacket if you're working in a radioactive lab, or in a in a power plant where radioactive materials are being used. That way, if you are a worker in such a lab, if you start hearing more clicks, that means that you are in a region where there's a lot of radiation. So you have to be careful with that, because these radiations are dangerous, and the dangers will be discussed later on. Now another way of detecting radiations is by the cloud chamber. So the cloud chamber actually has a cool gas inside. It has cool vapor inside of it, and this is usually used for studying alpha particles. So as particles enter the chamber, if there are any in the room, they will enter the chamber somehow, and they will basically cause the vapor inside to become ionized, and that will basically leave these thin tracks, if you can see them. And these tracks basically are cloud trails. You must have seen sometimes up in the sky, if there's a rocket or there's something going across the sky, it leaves a trail behind it. So what you see in this chamber is very thin tracks of clouds that are being left behind by the trail of alpha particle, and that trail can be studied to actually learn the properties of alpha particles. So this cloud chamber is pretty old technology, and it's not really widely in use now, and they are now replaced by something called bubble chambers, and they can detect more and more different types of radiations, not just alpha particles but a lot of other stuff as well. So these are the ways in which radiations can be detected. Now there are, so this was the second way. Now the third way can be photographic film. The photographic film is basically just a badge that you can wear. It's just a plate made out of some chemical. The chemical composition is not that important. Now this plate is shiny and all clean to begin with, but as more and more ionizing radiations hit the photographic plate, the photographic film, it starts blackening. So it starts to get darker and darker. And if you and these are basically used as badges that are worn by people in the lab. Again, it's a safety thing. So if you are working in a lab and you have this badge on in the morning and you're starting your work, the badge will be totally clean, and by the time the photographic film is black, you have been in the lab for a lot of time and you have had a lot of exposure to radiations. So a black photographic film is a sign that you have been exposed to a lot of radiations and now you need to take a break, because exposure to a lot of radiation can be dangerous. So this was the detection of alpha, beta and gamma radiations, and now we are going to continue this chapter in the next part.